safety devices, high limit switches. There's 2 of them on, two per unit. There's one in the back by the motor, which is in which senses the air temperature coming out. If you guys can see that, it's actually not in contact. It's not in contact with the sheet metal. It's actually in contact with the air passing through that discharge. So if you have a duct on here and there's a bend or something blocking the outlet of the duct, that will be the first one to trip. Because now it's sensing the temperature changing. And that one is only 190 degree rise. Actually, not 190 degrees. 190 degrees total. So if the temperature coming out is 190 degrees, the limit switch will trip. And both of these are manual reset. Again, like Garrett said, it's a CSA requirement for service that requires service. It's not just a auto reset where you just let it cool down and then it works again. The other one is located right in front. Both of these guys are in series with the gas guide. So if either one of these trip, you're not going to get 24 volts to your gas. So, and this one here is 275 degree rise, 75 degree temperature limit switch. This one is coming in contact with the actual heat chamber. So, if for some reason, again, the flame happens to roll back, that would be the first one to go. If you're not getting 24, check those two guys out. The other safety device is the air coolant switch, which is just a little paddle that's coming almost in the path of the airflow. Airflow moving, closes that switch, the control board will continue on with the cycle. The sequence of operation is air coolant closes, ignition will send out, the ignition board will send out voltage to the igniter. If the air coolant switch doesn't close, eventually the board will lock out. It's probably saying that my motor's not running or my fan is not moving, I'm not going to open up the gas. Basically, that's what it means. If the switch is already closed, it's not going to allow that either. Because now it's saying that, well, if that's closed, my valve is opening, I'm not going to send the igniter to start sparking. So that's the same thing. So air coolant switches, high limit switches are 2 of the main safety features on this unit. So keep an eye on those guys. If your motor starts, but you're not getting spark, that might be the first thing you might want to look at too. If your air coolant is not closing, it's not going to spark. If it's sparking, then it's not your air coolant. I got called the other day actually. He replaced everything in his heater and said, well, nothing's working. I said, well, what'd you do so far? He goes, well, it's not sparking, so I changed the high limit switch. Okay, I kind of wonder why did you do that? Well, I'm not getting 24 volts. Yeah, you're not getting 24 volts because your board is not starting anything, nothing's working. So he ended up just replacing the air coolant switch at the very end, and it finally worked. So kind of eliminate the gassing process. If you're going to replace the high limit, but it really has nothing to do with the high limit, it's really going to be a waste of your time, and it's just going to cost you guys. The heat chamber is where all the, if you imagine this, the heat chamber, the burner casting goes up here, flame goes up, and goes out this way. That is the place. Your casting is sitting right about here. Your flame comes up, it rolls over, and comes up. That's basically what the heat chamber does. You keep that flame enclosed inside this burner box. It just goes up, the fan blows, it's sucking that flame over and it blows it right up. That's all that is. So, just a totally enclosed box for the combustion to occur. Fan wheel is what moves that air out of there. Motor, if it's a particular fan heated air to move the air out. Each motor has its own different horsepower. I don't exactly remember which one is what, but they all have different sizes, different horsepower. fan housing, squirrel cage, just the mechanical, the sheet metal box that holds the fan and motor together to help move the air out. That's basically all that box. Regulator. Taking high pressure, dropping it down to low pressure. Main job is that's what it does. Now the dual fuel, this one is for the dual fuel 80. This one here is for the dual fuel 170. Now obviously you can see the difference on the 350. Different, the reason why is the capacity, the BTU capacity flow. This will have a maximum of 100, I think 100,000, so you can use it on the 80. This one have a maximum capacity like 200, so you can use it on the 170. Can you use it on the 170? You probably could, but you're not going to get the 170,000 you paid for. Can you use it on the 80? Yeah, you could. It definitely work, but it costs more. So, if you want to just keep one in stock, you can do that. But each heater comes with a regulator too. So, if you're saying, well, we just want to keep one, you're going to get one regardless, but it's up to you. But you just can't use this on the 170. It doesn't have the BTU flow capacity. But this one can, and you can use it on both. It just costs a little bit more down the road if you need to. Now the single stage, not single stage, single gas supply. This is the one for the 170. It's just a single stage regulator. Take steam pressure, drop it down to 11, 13 inches for operating on both the 170 and the 80. Now you can use this one on the 80 too. The 80 does have a different regulator. It's a small regulator again, it deals with flow capacity. But it doesn't hurt for you to have this on the 80. So you can use this on the 80, you just can't do it the other way. You can't use the 80 regulator on the 170. It doesn't meet the max flow capacity.
We get a lot of people doing that because, like Danny's talking about, you can standardize on regulators. And the same thing holds true on gas hose. I'm just going to get something right here.
The universal gas hose?
Yeah, this right here, this is something that we made, quite a few years ago, this universal hose kit. And this is just a 10-foot hose section. We make a 10, a 15, 20, 25. And you'll notice that it comes with multiple hose adapters. Yes, it costs more than a 3/8-inch hose, but what people will do, hey, what's my gas hose for my Premier 80? Well, it's this, but how many Premier 80s do you have? Well, we've got 10 in our fleet. Well, you could order this universal hose kit right here, and then you could standardize straight across the board on this stuff. You've got multiple adapters to connect to the outlet of the regulator or the gas inlet of the heater. So you don't have to worry about, what type of hose adapter do I need to get, any of that stuff. So, a lot of people have ordered specifically this kit right here. And if you look on the frequently asked questions sheet that I handed out, down toward the bottom of the front page, second bullet up from the bottom, it talks about, hose kits, can I use it on forced air heaters and so on and so forth. Well, this will work on any forced air heater that we supply. Any of those tradesmen, 170s, the 400s, Premier 350, or excuse me, not the 350, the 170 dual fuels, the 170 LP natural gas, and the same for the 80s. The only heaters that it won't work on is on the 350 because that takes a 3/4-inch hose. And, Dan will get into this on the big 500 dual fuel, that takes a 1-inch hose. But otherwise, it's just something you keep in your hip pocket to help standardize on your fleet of heaters. So I just want to mention that.
Thanks, Joe. Another question about regulator is, can I use, if I have a standard LP 170, and now I'm converting that to natural gas using a conversion kit, can I still use the LP regulator? The question to that, Jim, correct me if I'm wrong, the question to that is, the LP regulator, some of those LP regulators are not approved for natural gas use, through UL or CSA. Alright? Even though they have the flow capacity, you're not gonna get the same BTU because there's an orifice inside that regulator that will regulate that flow. So you're saying, well, that's 170,000 BTU regulator, it should be working, but you're not gonna get the same flow. Different characteristics between the gas, so it's not gonna give you the same effect just because it's a regulator and a regulator. So, now going back, stepping back a little bit, what if I have a dual fuel LP and I switch it to natural gas and my inlet pressure is only, let's say, half a PSI? Do I still need a regulator? The gas valve, the Honeywell gas valve, will be able to take that half a pound, which is only 13 inches, 13 and a half inches.
Right.
Take that 13 and a half inches and still operate normally. Anything above 2 pounds, then yes, you will need a regulator for natural gas. So if it's only 13 and a half a PSI, you don't need a regulator for natural gas. These gas valves have a built-in regulator that will take that 13 and drop it down to the proper manifold pressure you need to operate the gas valve. So that's one question we often ask, and those are actually 2 questions we commonly ask. Can I use the same regulator on both natural gas and LP, or can I not use a regulator on natural gas? And those are the questions that we normally ask. People will ask you guys too eventually when they do conversion, they'll ask you that too.
How often do you run into greater than 2 pounds of pressure on natural gas?
Depending on the length of line they're running. If they need to deliver a long distance, then yeah, you will need 5 pounds or 10 pounds. But at that point, yeah, then you will need a regulator at the very end because it's hard pipe. It's not going to be, you're not going to get a. And as silly as it is, somebody asked me, can I get bottled natural gas? So, I haven't seen that yet, but if you have, kudos to you.
For testing, we have obtained from a gas company that specializes in different types of gases for hospital use and so on and so forth. They'll get us compressed natural gas that we did use for testing out here on certain types of heat. But out in the field, I mean, you're just not going to be able to get that.
It's all going to be hard pipe. Yeah, it's going to be a hard pipe then. So, like I said, depending on the distance and the pipe sizing, you could go up to 5 to 10 pounds. So, if it's half a PSI, you don't need a regulator. Tap it right into the gas line, hooked up the heater. Jim, anything to add on the regulator?
No, I mean, just to, reiterate something, right? Those Honeywell valves, these Honeywell valves, like this is the 2-stage one right here. And these Honeywell valves basically are a low pressure regulator in their own right. They will take a half a pound inlet pressure. In fact, once you lock it up, shut off the heater, they can take up to like 18, 19 inches, lock up pressure and open up against it. When the pressure is flowing, you got about 13, 14, 15 inches water column coming into this valve, which is still less than a pound of pressure, just a tad above a half pound. There's a little regulator in, well, this is a 2-stage, but the top off right here and take this out. There is a little low pressure regulator that you can adjust to take the pressure and reduce it down to what the actual outlet pressure is, what you want to achieve on this valve. So it's built somewhat like a regulator that Dave's been talking about. It's got a little diaphragm in it, a little bit of channels of orifices and so on and so forth to create a high pressure and low pressure drop for that valve. So it's a low pressure regulator in its own right, but it only works within a window of gas pressure. If I supply 2 pounds to this valve, it's going to lock up. It won't let any gas come through. Right? So that's where you're going to need a regulator.
On the 2-stage gas, you can see there's actually 3 terminals. One terminal is down, one terminal is low heat, and one terminal is high heat. Those are the solenoids. So even though you're getting 24 volt, you're only going to get supplying 24 volt to your low side. Make sure you get getting terminal, your power to your actual solenoid, to your high stage solenoid. Alright? So the heater might be operating on running fine, but if you're not getting voltage here, you're not running on high heat at all. So, and that's separate terminal, separate connection.
I'm sorry, I didn't mean to interrupt you, Dan. But that 2-stage valve is on the Premier 350 LP or natural gas. That's the type of valve that is supplied on that. The dual fuel, do we have just a single stage?
Yep, that one went around already.
Okay, that went around, yeah. That standard one, or the one without the solenoid hanging off the inlet end of it, that one that those guys have over there is used on just the standard Premiers and the dual fuels. But when you get into this two-stage valve, that's what you can expect to find on the LP or natural gas Premier 350. Like what Dane said, you know, the first stage of the valve opens up, it's coupled with a two-stage thermostat. If you put your hand on there and you feel, geez, this doesn't feel hot enough, then what you're probably going to have to do is come back to the wiring on here where it says high, turn up your thermostat all the way to the highest heat setting and see if you're getting 24 volts applied to the high heat terminal. If you're not, then it's your two-stage thermostat that's the problem, or a wiring connection. You get the idea.